Every application you use, from social media feeds to banking systems, processes massive, chaotic streams of raw data every second. To build software, you need a way to capture and organize that information so it doesn't get lost in the noise. Look at this 3D storage box. In programming, this is a variable, your primary tool for catching and managing those digital data streams. On screen, we create a minimalistic container, give it a precise label like name, and drop the text Hablu directly inside. Once stored, you never type the original information again. Simply call the label, and the exact information projects right back to you. Mastering these data containers is step one. Before you can build algorithms or functional software, you must know how to store your data securely. Let's open up our code editor and translate this concept into actual Python code. Look closely at this code block. We write our label, name, use an equals sign to assign the value, and type the word Hablu surrounded by quotation marks. Notice how those quotation marks pulse. They tell the computer to treat the data specifically as a text string. Without them, the system tries to read the text as a command, fails to find one, and crashes. Storing the data is only half the process. We need a way to verify it actually saved. For that, we use the print command. By typing print name and running the script, we see the output here in the system terminal. The text Hablu appears perfectly. The terminal acts as your primary diagnostic tool. When the output matches what you expect, you have absolute proof your information logic is working exactly as intended. While text strings handle names and messages, programming also requires the storage of numbers and logical states to function. Look at this breakdown. We have distinct columns for our information: text, numbers, and a third type called booleans. For numbers, we use integers. Notice how age equals 20 drops into the number column without any quotation marks. Python automatically recognizes pure numerical data and processes it mathematically. Finally, we have booleans. These act exactly like a switch, storing binary logic states that are strictly true or false. Here, we set isStudent to true. Now, let's take these individual data types and combine them to build a practical project, a student information profile. We start by defining our variables one by one. First, the string for the student's name, then the integer for their test marks, and finally, a boolean to confirm their active enrollment. On their own, they are isolated fragments, but when we pass all of these variables through our print command sequentially, they form a cohesive data output. Here is the output. The code generates a student profile record, pulling the name, numerical marks, and status directly from the raw data we stored. Organizing different data types into structured variables is the primary method used to build information systems and user profiles. Before moving forward, there is a common syntax trap that will cause your code to fail. Take a look at this specific error. Student name equals Rahim. Notice the red warning targeting the empty space right between the two words. A computer compiler reads an empty space as a hard stop. It sees two separate, undefined commands instead of a single variable label and immediately stops the script. To connect words safely, we use an industry standard called snake case. By inserting an underscore to bridge the gap, the label becomes one continuous string that the computer can read. Using clear, unbroken naming conventions ensures the Python interpreter can read your logic and execute the script without errors. You just wrote, structured, and verified your first working multivariable Python script. You started by understanding abstract storage containers, learned how to safely assign strings, integers, and booleans, and outputted a functional data profile. These rules for managing information will apply to every project you build as you move toward more complex programs. Now it's your turn. Open your editor and apply this logic to build your own custom datasets. Subscribe to the channel to see how we use these variables to build more advanced logic.